This session is on the second part of the workshop on new network and services ecosystems for 6G, the networks aspect. In the morning half, we did the services aspects, and now we're doing the networks aspect. This session will be run by Professor Radhakrishna Ganti, professor at IIT Madras. He's also a member of TSTSA and has been a long-time contributor to ITUR, Working Party 5D. Over to you, Professor Ganti.
Thank you, Bindu, for inviting me here and the warm welcome. So, welcome everyone. I mean, I see a lot of friends here. I mean, after a long time meeting them in person, very, very happy to be here. So we have a good session planned. I mean, unfortunately, most of the people, other than two of us, everyone is online. So this is about this particular session is about new network ecosystems for 6G. So in this session, we look at what are the newer technologies such as an NTN, AI/ML from a very higher perspective, and see how they fit into the whole 6G framework. So we have a wide range of wide range of talks planned, and including a good panel discussion. So without without further ado, I think I would introduce the first speaker, Dr. Atarashi from ITUR. He's ITUR WP5D chair. Just let me, I'm not able to see this properly. Dr. Atarashi is a senior manager in the Spectrum Planning Office at NTT Docomo. Since 2006, he has been involved in the standardization activities at in the IMT at ITUR in APT. Starting in 2024, he has been serving as the chair of ITUR Working Party 5D, which is responsible for studying the overall radio aspect systems of IMT systems from both spectrum and technology aspects, technology perspectives. Actually, he has helped us quite a bit when we doing the LMLC and the 5GI journey, so we know him very well. So welcome, Dr. Atarashi. So he'll be talking about, just 1 minute. So he'll be talking about IMT 2030 developments in the ITUR WP5D. Just to give a brief perspective, currently ITUR is working on IMT 2030. It's looking at the KPI documents, the technology documents, what goes in, what are the specifications of IMT 2030. And he has been heading the whole thing, so it's best to hear from him on how IMT 2030 is being framed at ITU. Welcome, sir. The stage is all yours.
From my side instead of your side. So if you allow me to share my screen. Yeah, thank you. Yes, thank you very much. Good afternoon, everyone, again. So this is Hiroyuki Atarashi, the chair of ITUR Working Party 5D, speaking from Japan. It is a great pleasure for me to attend this workshop and a great honor to deliver the keynote speech today. The topic of my presentation is IMT 2030 developments in ITUR Working Party 5D. IMT 2030 is a terminology defined by the ITU, but please consider this term equivalent to 6G in general context. And before diving into the details of IMT 2030 development, I'd like to first provide some background of ITUR activities. As you can see in this figure, the International Telecommunications Union, ITU, is divided into 3 sectors, ITUR, ITUT, and ITUD. My focus is on ITUR, which is primarily engages in 2 major activities, the World Radio Communication Conferences and the work carried out by the study group. Within ITUR, under the Radio Communication Assembly, there are 6 study groups, each tasked with different subject. Among them, Study Group 5 is responsible for the terrestrial services, and Working Party 5D is one of the subgroups under Study Group 5. And this slide explains the role of the ITU in IMT development. One important role is related to spectrum matters, particularly achieving global harmonization of IMT spectrum. This has been accomplished through decisions made at the ITU World Radio Communication Conferences, WRCs. And global harmonization of the spectrum is crucial for addressing the needs of both developing and developed countries. Another important role involves the technical aspect, such as the standardization of IMT radio interface technologies. This has been accomplished by developing ITUR recommendations that addresses the specifications of IMT radio interface technologies. And in this context, ITUR Working Party 5D is responsible for studying the overall radio system aspects of terrestrial IMT, considering both spectrum and technology perspectives. And this slide briefly explains the achievement of WRCs and development of IMT technology over the years. In 1992, which was what was then called WARC 92, was the first to identify frequency bands for IMT in the 2 GHz range. These 2 GHz frequency bands were utilized for 3G technology globally from around 2001 onwards. For 3G technology, ITUR developed ITUR recommendation addressing its radio interface technologies, such as WCDMA, CDMA 2000 under the term IMT 2000. Following that, subsequent WRCs 2000, 2007, and 2015, 2019, 2023 identified additional frequency bands for IMT. Regarding the technology, after the introduction of 3G, new generations such as
there's a small technical glitch. Can you just hold for just 10 seconds? They're just rectifying it. Just 10 seconds. The online people are not able to hear this talk. Just 10 seconds.
Okay.
If you can just hold on, I will just tell you.
Yeah.
Thank you, sir. You can restart. Thank you.
Yeah, thank you very much. So I will start from the beginning of this slide. So this slide briefly explains the achievement of WRCs and development of IMT technology over the years. In 1992, at that time it was called WARC 92, was the first time to identify frequency bands for IMT in the 2 GHz frequency range. And these 2 GHz frequency bands were utilized for 3G technologies around 2001 onwards. For 3G technologies, ITUR developed an ITUR recommendation addressing its radio interface technologies, such as WCDMA, CDMA 2000 under the term IMT 2000. Following that, subsequent WRCs in 2000, 2007, 2015, 2019, 2023 identified additional frequency bands for IMT. Regarding the technology, after the introduction of 3G technologies, new generations such as 4G, 5G were introduced approximately every 10 years. In I2R, the radio interface technology for IMT Advanced and IMT 2000, which corresponds to 4G and 5G respectively, were specified in the relevant I2R recommendations, achieving standardization of these generations radio interface technologies. Currently, I2R has initiated the standardization process for IMT 2000 radio interface technologies, which corresponds to 6G. And today's my talk is focusing on this 6G IMT 2000 development in I2R. I will explain this in the following slides. And before initiating the actual standardization process of IMT 2030 radio interface technologies, I2R has developed a new recommendation addressing the framework and objectives of IMT 2030. This recommendation is I2R M.2160, which includes well-known symbolic figures explaining IMT 2030. You may already be familiar with these figures. One symbolic figure depicts usage scenarios of IMT 2030 as shown in this slide. This figure outlines 6 major usage scenarios for IMT 2030. The scenario indicated in green, this part, is extension of the IMT 2020 5G usage scenario. In IMT 2020 5G, the usage scenarios were represented by triangular shape, including enhanced mobile broadband, massive machine-type communication, ultra-reliable low-latency communications. In IMT 2030, these scenarios are expected to evolve into immersive communication, massive communication, and hyper-reliable low-latency communication. Additionally, IMT 2030 introduces 3 new scenarios: ubiquitous connectivity, AI and communication, and integrated sensing and communication. And as overarching aspect, keywords such as sustainability, ubiquitous intelligence, security and resilience, and connecting the unconnected are specified. Another symbolic figure shows the capabilities of IMT 2030. This recommendation identifies 15 capabilities, and some of them are enhanced capabilities compared to IMT 2020, while others are new capabilities to IMT 2030. In this chart, the envisioned targets for these capabilities are also indicated, shown as single or multiple values within each capability. And this slide shows a simplified timeline for the development of IMT 2030. In 2023, the framework recommendation, which I just explained, was completed. Following that, I2R Working Party 5D began defining the requirements, evaluation criteria, and methodologies for IMT 2030 development, which I will explain further later. And starting in 2027, Working Party 5D will receive candidate IMT 2030 radio interface technologies and evaluate whether the proposed technologies meets the IMT 2030 requirements. In 2030, a new recommendation for IMT 2030 radio interface technologies is expected to be finalized. Aligning with ITUR timeline for IMT 2030 developments, 3GPP will begin its study for 6G in the Release 20 timeframe and conduct normative work during the Release 21 timeframe. I anticipate that 3GPP will submit their candidate technologies for IMT 2030 submission process by ITUR. And this slide provides more details on the IMT 2030 development process. This process is based on the collaboration between ITUR and external ITUR bodies. First, ITUR defines requirements for IMT 2030 radio interface technologies and establish their evaluation methodologies. And this will be done in the time frame between 2024 to 2026. Then ITUR invite proposals for IMT 2030 radio interface technologies and their subsequent evaluations. This has been already done. I will explain it in the next slide. And based on this invitation, development of the candidate radio interface technologies for IMT 2030 will be done by outside of ITUR. And example of this activity will be made by 3GPP. And those organizations will submit their candidate technology proposals to ITUR. And ITUR will receive submissions of candidate IMT 2030 radio interface technologies proposals. And this will start from 2027. And ITUR will review and coordinate evaluation activities conducted outside of ITUR. And actually, ITUR asks independent evaluation group if the proposed technologies meet the requirements defined by ITUR. So this technical evaluation of the received proposal is also conducted by outside ITUR. Then based on the evaluation result, ITUR will decide whether the proposal meets the criteria of IMT 2030 technologies, and if that is the case, that technologies will be included in the relevant ITUR recommendation for IMT 2030 radio interface technologies. So this is the overall process made between ITUR and outside of ITUR. And in order to call for the IMT 2030 radio interface technologies, ITUR defines the requirements for IMT 2030 radio interface technologies and establishes their evaluation methodologies. For this process, ITUR is now developing 3 new ITUR reports. The first one is report ITUR M.IMT 2030 technical performance requirements, which outlines the minimum requirements related to technical performance for IMT 2030 radio interfaces. The second is report ITUR M.IMT 2030 EVAL, and this report will provide guidelines for evaluating radio interface technologies for IMT 2030 proposed by others. And the third one is report ITUR M.IMT 2030 submission, which details the requirements, evaluation criteria, and submission templates for the development of IMT 2030. These 3 reports are expected to be available by the end of 2026.
Dr. Atrashi, you have about 5 more minutes, please.
Yes, these slides provide recent highlights in IMT 2030 development. In October last year, ITR issued a circular letter announcing that the process for developing IMT 2030 radio interface technologies had officially begun. This letter calls for proposal for candidate radio interface technologies for IMT 2030 and invites participation in the subsequent evaluation process. This information was also sent to external organizations, including 3GPP, and I also believe that it was also sent to TSDSI. Therefore, you might already be familiar with this. This slide shows the achievements from February this year. During that meeting, a preliminary list of minimum technical performance requirements for IMT 2030 was created. This table might be difficult to read due to the small font, but it includes a list of minimum technical performance requirements that were preliminarily agreed upon. In this table, traditional requirements such as spectrum efficiency, latency, mobility data rate, and others are listed. Additionally, you will see new types of requirements such as AI-related capabilities, sensing-related capabilities, positioning, and so on. And this slide provides the most up-to-date information on IMT 2030 development. From the end of June to the first week of this month, the Working Party 5D meeting was held in Japan. During that meeting, progress on the development of 3 new ITR reports was as follows. Regarding the requirements report, the working document was further updated. I heard that there were some challenging discussion on some of the requirements. And we also received several proposals that provides for the minimum technical performance requirements value. But due to time constraint, they were not fully discussed. Regarding the evaluation methodology report, the working document was also updated. I heard that there was good progress in some areas for this document. Regarding the submission report, this was almost the first meeting to initiate work on it, and the working document with a table of contents was created. And this slide explains the benefits of the global harmonization in terms of mobile spectrum and technologies. I do not explain the detail, but I think the collaboration between Working Party 5D and external organizations, SDOs, including TSDSI and 3GPP, and so on, is crucial. Here is my final slide summarizing the key points. As I mentioned, the international process for the submission of IMT 2030 candidate proposals, their evaluation, and eventual standardization in the 2030s is well underway. And Working Party 5D is currently focused on establishing detailed IMT 2030 requirement and their evaluation methodologies. Actually, the Working Party 5D meeting scheduled for February next year is planned to be held in India with support from the Indian administration. I would greatly appreciate their support, and if you are interested, you are welcome to participate. With that, I conclude my presentation. Thank you very much for your attention.
Thank you, Dr. Atarashi. So we will take the questions at the end of the session so that we can keep the whole thing going. Thank you again. The next speaker is Dr. P. Hanumantarao. He is DG Samir. Dr. Hanumantarao, Director General Samir, has 34 plus years experience in RF, microwave, and millimeter wave R&D. I mean, just to tell you, a lot of missiles, antennas are designed by him. Most of you don't know that. He has led indigenous 5G tech development, including India's first MIMO, massive MIMO demos, a key contributor to national strategic projects and standards. He collaborates with IITs and global institutes. His current research areas include 6G solutions, IRS, UAV detection and deactivation, spectrum studies, and tiled phased array systems. Dr. Rao, the floor is yours.
Yeah, I'm around.
About the local Indian perspective, the 6G technologies from Indian perspective. Sir, you have 15 minutes. Since you're local, we are cutting down 5 minutes for you.
No, that's okay. I just want to take them through what India is doing, especially a lot of initiatives which has been done there. So I don't touch much on the 5G because next talk maybe talking about 5G and 6G, the initiatives from Bharat 6G Alliance. So I'll talk about some of the key technologies which India is focusing and building. Next slide, please. So some of the areas which there's going to be a lot of discussion happening there, which probably I'll try to focus on that what can be done on non-terrestrial networks and combining terrestrial non-terrestrial networks. Though it is not really has gone into the 6G standard, we're anticipating that it may come in future. So I'll try to focus more on that aspect in the end of the talk. And first, initially, I take you through the two key technologies of intelligent lifting surfaces or reconfigured intelligent surfaces and orbital angular momentum, which are expected to be two key technologies which are going to make 6G as a reality. Next slide, please. Of course, this is known to everybody. It's from the WOI. It's one of the nicest slides to say that what 6G is going to be. It's going to be more of a connected intelligence. So there's another area which a lot of work need to be initiated there in terms of joint communication sensing. So that's one area probably India has been a little back on not attempting much. So though we are making the radios and antenna systems, the RF systems, probably there's one area which we need to go a little further and to say that we can make a joint communication sensing as a reality. A lot of theoretical work has been done, but not much of a practical demonstrations on that aspect. Next slide, please. This is one of our achievements of the 5G, as Professor R.K. Ganti has mentioned. So IIT Madras, Samir and IIT Kanpur, and of course, the 5 more collaborators will build the solution. But basically what has gone into the system is from all these 3 institutes, and we deployed there as a secure network and a standalone solution, not depending on the service provider. And it's a fully functional system there, meeting entire 5G stack as per the ITU standards. Next slide, please. There are some of the very key technologies which we built, which going to be engaged there into both strategic and civil applications and transposing into 6G also. The tiled array technologies for the completely having a control over the beam as a full-fledged phased array, and it has both the complete electronic phasing system and the hybrid MIMO also. So we have the 2x2 MIMO and we have the full-fledged beam steering in the both azimuth and elevation planes. Next slide, please. So of course, these things are mostly things, clear about a lot of the people who have been sitting there and listening. But the few areas which, as Indian perspective, Samir and IIT Madras and a few other academic institutions working, are typically to realize a complete radio or wireless system at this stage, because all the protocols are not ready yet and we don't have the interfaces, standards are not been up. So keeping that in mind, at least we know the frequency which are going to come around. If not now, by next year, we know the frequencies. So we started focusing on both bands. We expect to be FR3, maybe around 7 gigahertz band, and other band maybe in the D band and sub-terahertz 300 gigahertz band, 140 to 300 gigahertz bands. Both bands, we started building the components, radio components, so that when it becomes a reality, the standard comes, at least we have indigenous solution. We have our multipliers, we have the mixers, we have the filters, and we have the PLLs. All these things are homegrown technology. Of course, including the design to the fabrication to the packaging, entire then done in-house within the organizations. So that is one thing which we started changing the entire approach. Though it's going to wait for, instead of waiting for till the standard up and start working, at least all the radio components which we know is not going to be much different than more or less frequencies are getting it frozen. So we started focusing on building those subsystems which are going to be the prime components for the future radio system. So that is more of a, you think of the, especially for part of the RAN solution. Then as I said, like the full duplex is other attempt is being done, especially from IIT Madras. Professor RK is leading that along with Professor Aniruddhan. That's one thing probably we envisage that at least in 2 to 3 years time, we'll have one functional, fully in-band, full duplex system demonstration within the part of the 2 initiatives what we have taken. Then third one, I said we are working on, slowly started moving on to terahertz. I mean, then to terrestrial networks, non-terrestrial networks. We're working with the Indian Space Research Organization. If you can get us a kind of at least one transponder available to us, we have been discussing with at very high level, so that we'll try to demonstrate one non-terrestrial network from the ground to the airborne platform and back. Not meeting the typically all the standards, at least we want to establish a kind of an integration of terrestrial non-terrestrial network. There's one initiative which India is pursuing it. Next slide, please. Next slide. These are some of the frequencies, like 3.5 to 6 has been our 5G. People expecting going to go around 7 gigahertz, something around between 6.7, 7.12, depending upon the countries which are working. And the other bands which people are looking at the very high frequencies, especially millimeter bands, talking about 75 to 110 gigahertz, on some in D band, 110 to 170 gigahertz. A lot of propagation studies have been done at 140. Then one more frequency which we are attempting is sub-terahertz bands, which is 300 gigahertz. So we are doing one development at 140, other development 280, so that things becomes compatible at the frequencies, and remaining some of the sub-components which are built at D band can be exploited of the sub-terahertz band. Next slide, please. These are the two major initiatives, at least a fully functional end-to-end solution. You can talk not on a 6G end-to-end. As a RF system is concerned, one is AI-driven IRS-based communication, and we are doing at two frequencies. 140 gigahertz is a static IRS, and at 7 gigahertz is going to be completely dynamic, fully functional IRS with in-house algorithms and the complete, fully functional, homegrown and indigenous design of the IRS solution. And we are building the entire wireless link. Baseband is coming again from IIT Madras. We're taking the multi-layer approach, taking the multiple channels of basebands, combining them, each one of them up converting to different frequencies, then getting a bandwidth of 10 gigahertz bandwidth, so that we are anticipating to demonstrate next IMC in month of October, around 100 gigabits per second data, what we anticipate to showcase over the wireless and line of sight communication. Non-line of sight communication will try to do at 7 gigahertz using IRS. We already made a few measurements how to send the data to IRS. To our excitement, results are very, very encouraging. Sending the data through IRS, the deviation or maybe the loss in the signal is not that predominant compared to a standard reflection. So we're able to steer the beam, and we're able to get the data to reasonably acceptable range and good SNR. Then other project what we are handling there again is funded by Department of Telecommunication. It's a large project. IIT Madras, Samir, IIT Guwahati, IIT Patna have been involved. And the first project, Samir and IIT Madras are involved. One is funded by Minister of Electronics and Information Technology, my parent organization. Other one is Department of Telecommunication. Both are government funded projects. Second project has a lot more deliverables. We are building the sub-terahertz components, of course, ranges from the multipliers, filters, and we have the mixers, then power amplifiers. There's one side on a subsystem level, and parallelly we are building a full-fledged IC at 270 gigahertz. Then we're building the antenna system, lens-based high gain antennas going up to 56 dB gain. So that's like huge amount of the gain when you think of the terahertz. And we anticipate to get a link about 100 meters link with 100 Gbps data to maintain the required SNR. And we are building IRS, the static IRS at 270 gigahertz using the 3D printing technology. Graphene is printed on a silica press substrate. Then on top of it, we're able to steer the beam for a designated directions. And once you get the components, probably we need to shift onto the dynamically steerable IRS. And another technology what mentioned, orbital angular momentum, how to generate the data for the different modes and send the data simultaneously so that you get the large data. It is a parallel to the MIMO. It's not a substitute to the MIMO, but instead of having a polarization diversity, what we have only 2 degrees of freedom, right and left hand CPR, stand 45 minus 45. Here we have multiple modes which can send the data simultaneously to all the modes, but with one limitation, other than the mode 0, the signal get diverged, the beam gets diverged. Now we had few research, few attempts have been done to how to decrease the divergence and bring the beams closer so the data can be transmitted simultaneously. Next slide, please. This is the first project. As I said, in March 23, it was offered to us. And 2 years time, at least in a year's time, in a year and a half, we're able to demonstrate. We can see on the right side, and Professor RK and myself, we're able to demonstrate over the air 6.4 gigabits of data. So that is kind of a massive data transmission over the air. It's a live demo. It's not the post processing, and it's, of course, there's no. I mean, LNA wasn't there on the receive side. Probably we can have the much better performance there over the long range. It is demonstrated over the 30 feet length, the distance between the transmitter and receiver. Next slide, please. I'll show how it looks. So we don't implemented the OAM yet there. It's a simple, I mean, we use the OFDM there and 64 QAM, and we send in a single channel with a bandwidth of 5 gigahertz bandwidth, and we're able to demonstrate the 6 gigabits per second. This is the final setup. What we envisage to do at least end of next year, we'll have fully functional multi-channel 5-mode OAM transmission, expected to get 100 Gbps data, live data over 100 meters distance at 270 gigahertz. Next slide, please. Next slide. This is typically to get the feel about what IRS does, what OAM does. You have a simple difference between the angular momentum, that is what we call a spin angular momentum, which is circular polarization, right hand CP, left hand CP. Other one is orbital angular momentum. You can see the phase front. Basically, the vector is an helical phase front and compared to the circular phase front. So that in turn gives the degrees of freedom. Depending on the orientation of the phase front, we'll be able to manage multiple modes and we're able to transmit simultaneously the data. Next slide, what we do is in IRS, based on incident angle, we are able to steer the beam by controlling the reflected phase out of the antenna system. So there is a basic, we don't call an antenna as reflecting surface. The beauty here is there are no phase shifters. We just have only 1 or 2 states of biasing. If you think of a varactor diode, I bias the varactor at 4 typical voltage values for a bias there, 10 volts or 4.5 volts, 3 volts and 0.2 volts. For that, there's equal amount of the phase, what we get the reflected phase from the antenna system. We load this varactor onto the antenna element and we combine them and we do the pre-phasing. Instead of controlling each element, suppose we have 20 by 12 elements, we group them into four channels. Each is having 0 degree phase, 90 degree phase, 180 degree phase, 270 degree phase. Based on that, with the algorithm takes care of it, you want to steer the beam, which portion of the elements within the array should have 0 phase, which should have 90 degree phase, which could have 270 or 180 degrees. Next slide, please. We build the entire IRS. Next slide.
Dr. You have just 5 more minutes.
Sure, I'll be closing it. Next slide, please. So you can see that when the angle of incident is 30 degrees, we want to steer the beam for the different angles, minus 20, minus 10, 0, plus 10, plus 20. You can see how the complete the tile looks. The colors, you can see the red, green, black, and blue. So they change depending upon what amount of the reflected phase required. So entire surface, though it is discrete, it looked as a single surface and create the required phase so that beam can be steered over an angle. We did it at multiple incident angles. Next slide, please. Is a minus 20. Automatically, the entire the tile, the phase front over the antenna array changes, or the reflecting surface changes, and we're able to steer the beam. Next slide, please. Keep going on. Keep going on. Next. These are the old things why we wanted OAM. So these OAM typically keep going. We have the multiple modes. Because they are simultaneously transmitted, they're orthogonal to each other. They don't interfere with each other and sending the data on multiple channels. Go to the next slide. In a particular channel, we have 4 to 5 modes and we multiplex them into more number of channels. Next slide. Then we'll get the large amount of the data. We can go even up to, theoretically, we can get, if you get maybe 100 gigahertz bandwidth, you're able to get 1 terabits per second data possible there. Next slide. Next slide. Next, please. Next. This is OAM. So we built some of the OAM. Hold on this. Next slide. This is the place where I need to spend a couple of minutes on it. So if at all we want to make the 6G reality, even at 7 gigahertz band or at 140 or 270, what are the higher bands we choose? Some of the things still been not addressed yet. You see in the previous presentation from for IMT 2030, what we're anticipating. But still, these things are yet to be studied. One is the spectrum and the interference. We need extensive studies in the urban development and rural developments and how it's going to behave. 7 gigahertz, we have some models, but not at 270 gigahertz. Then the devices. The device is always a challenge. High power devices to get on board and thermals. Once you get them on board, how to get the thermal? You want to develop 16 by 16 MIMO, and you want to have the 10 watt power or 15 watt power per channel. You want to pump. And imagine at 7 gigahertz, you need to send the data over a distance. There's going to be quite amount of challenge there unless we get good amount of the gallium nitride amplifiers, or people are moving on the higher frequencies going to indium phosphide and silicon germanium. And of course, CMOS still does the combined both for the analog and digital. Then enabling materials are becoming a challenge for us. As the high frequency up to 7 we can manage. We're talking about 270 gigahertz. Materials are still going to be very, very major challenge for us to how to implement these technologies on which kind of material, still how to fabricate and realize it. There's a major challenge. The row can be handled by us. Both projects put together, we're able to do hand-on designs, modulation schemes, transceiver systems, and communication algorithms. But next, the question comes, when you're going to have a heterogeneous system, the hardware restraints, how to handle these. These are the kind of complex things which a lot amount of study which been initiated within the government initiative. The multiple projects have been given there. Then one small, maybe another 2 minutes, I'll talk about terrestrial, non-terrestrial network. Next slide, please. This is what we are demonstrating there in the coming IMT. The IMC in October to get data around 100 Gbps. Next slide, please. These are the subsystems we already built. We built at 140 gigahertz and 270 gigahertz, which can enable the wireless link. Now we have to process more on making the bandwidth is available there. On the baseband, we have to implement in such a way that baseband is done at lower frequency, at L band. We are converting into X band to get the 10 gigahertz bandwidth. Then converting 270 gigahertz transmit over the air. Next slide, please. These are all components are in-house designed, fabricated, and assembled. Then we came up with multiple algorithms, how to generate the multiple beams, how to control each beam independently, keeping one beam stationary, steering the other beam, or simultaneously steering both beams, how to control the amplitude of each beam and the direction of the beam. Next slide, please. Next slide. Next slide. And we can shape the beam contour. If you want to have a non-terrestrial network, you want to, only small area you want to cover with a typical contour by controlling the number of beams from the what you call spaceborne platform or maybe airborne platform. We're able to generate the contour in such a way that we can serve only the required area. Next slide, please. At the same time, we can decide some of the areas which are troublesome, we don't want the communication to happen. We can create a null. That portion of the area cannot be served. It can decide in such a way that we do in the entire mapping of the contour such that there won't be any signal at that particular location, geographic location within the main beam. Next slide, please. Next slide. This is the entire system what we're trying to demonstrate. Next slide. Next. This hold on here. This is the entire system. Now we are having as on we get 70% homegrown technology. End of maybe years time we'll have 85 to 90% completely homegrown technology of the wireless link at 270 gigahertz or 140 gigahertz. Next slide, please. We already built that. 1 minute. 1 minute. I need a minute more. Thank you. This is the IC which is built at 270 gigahertz. Final testing is happening there. We are going to package it there. Maybe in a month's time we'll have the results available. This is done by IIT Guwahati. This is a part of the project IIT Madras, IIT Guwahati, IIT Patna and Samir. Next slide, please. This is a static IRS been printed using graphene at 270 gigahertz. Testing is under progress. Next slide, please. This is IIT Patna. This is the OEM. We built it using uniform circular array. Next slide. This is using Spira plate. It's under fabrication. Maybe in a couple of weeks' time, we'll have the results. How divergence could be controlled using the Spira plate based OEM. Next slide, please. Next. Fast, please. Next. Non-terrestrial network. This is only one place where I want to talk a little bit on what need to be done. If at all we're having to have a regenerative payload, my gene would be going to get onto the airborne platform. How going to address it and how to generate the multiple beams. The algorithms what we built it going to be very handy. Create the multiple beams serving the multiple users, some for data, some for the broadcasting, some for the voice. So that's why I said non-test network approach is going to be the one of the key study items as per we are concerned. Next slide, please. Multiple applications. Next slide. Next slide. Next slide. I think that should be fine. Thank you.
Thank you, Dr. Rao. Let's give an round of applause to Dr. Rao. Sir, we'll hold back on the questions till the end of the thing, because you
Sure. Thank you.
Our next speaker is Mr. Sandeep Sharma. He is a member of the Governing Council of Bharat 6G Alliance. He's a VP and Global Head of Emerging Technologies Network Services at Tech Mahindra. He's a telecom leader with 20 plus years of experience in 5G, O-RAN, AI, and 6G. He drives innovation standards and strategic partnerships. As Vice Chair of the 6G Use Case and Revenue Stream WG at the Bharat 6G Alliance, he leads efforts to identify India-centric 6G use cases and foster collaboration across industry, academia, and government for AI-driven 6G solutions. He's going to talk about intelligent networks for 6G.
Thank you, Professor TSGSI, for inviting me here on this Friday afternoon. I know once you are a speaker on the second half of a Friday after a 3-day packed workshop, most of the things must be known to you, and I'll be not making it a boring session for you. I'll try to make all of you awake, because I'm talking about most of the things which you have heard, but with a different sense. As we are evolving to the next generation of 6G, I think many things are keep changing. Most of the things you feel is there in 5G, which was there in 4G itself, that will evolve to 6G, but there's a different flavor to it. And we as an industry should look at collectively how that different flavors could be met to meet the real expectation. Next slide, please. And this is the 6-point hexagon that all of us have seen by now, learned by heart. The main essence that I'm trying to make here is that in this 6-point hexagon, 2 points particularly I always feel that they are going to change the horizon of telecommunication significantly. One is the AI, that's going to be the integrated part of the networks. Other is the sensing. These two things are the things that networks have not experienced, as well as end users have not experienced these two things or capability the way it is being experienced today. Other thing is that till the time we were in, I would say, 4G, there was always a precursor of the services that we are using. For example, in 2G, there was always earlier land mobile phone. There was a need of communicating, and people are very much familiar, okay, we need to communicate. That's why 2G was a boom and success. When we evolved to 3G or 4G, there was a need of data that got generated, and we are very fond of watching movies either in television or in cinema. So people got a flavor, okay, there's something that we enjoy it. If it's giving us, it is being offered to us at a flexibility on phone, enjoy it. So there's a by default consumption of the use case that for which the technology was made of. But when 5G came in, there are new capabilities that most of the things we have not experienced earlier. Low latency, it's not a use case for a common public. End users are least bothered. Low latency is something for typical time-critical applications that industries must use, or the different industry in terms of healthcare, manufacturing should use. But we bring the technology, the industry was not aware of whether they need it or not. That's where we feel a problem of all these use cases are not being adopted in the industry the way it has to be. Now we are at a point of designing or developing 6G. Things are changing very fast, and the new thing that has ended up here is the AI. Most of us are using AI as an end consumer as well in our daily life. I'm sure most of you in the room must be using ChatGPT in a day 2 to 3 times. It is generating a new type of traffic, that traffic that network has not experienced. And the nature of that traffic itself is not known. Sometimes bursty, sometimes data consuming. We need to define how the network should behave around it. Next slide, please. So once this IMT 2030 vision was defined, our Honorable Prime Minister had given a vision of Bharat 6G to achieve leadership at a national level for 6G, at the same time with the three foundation pillars of achieving affordability, sustainability, and ubiquitous coverage. And there's a defined objectives, how it needs to be achieved it collectively for the nation. Different, I would say, organizations started working towards it. And Bharat 6G Alliance is aiming to achieve that leadership by collaboration across entities that exist within India and outside India as well. Having said that, things are not that simple as it looks like. We started talking about standardization. A lot many things started in 3GPP as well. But there is still a lot of collective thought that needs to be done as we move further to make this technology more accessible, more realizable in real terms. Next slide. In Bharat 6G Alliance, we formed the structure in a form that we have 7 working groups. These working groups are focused on different aspects of a telecom network, right from the spectrum, which is the ultimate foundation. It starts from there. It's the closest thing that comes to a user. That to the extreme of use cases, applications, infrastructure, everything. These work groups have their independent responsibilities, and I'm the vice chair of the use case group particularly, and a part of governing council as well. This chart actually demonstrates that there's a responsibility that we as an organization, Bharat 6G Alliance, have thought of before putting this structure into place. There are different organizations who are representing it. Some are chairs, some are vice chairs. And we do deliberations quite rigorously how it should happen, where we should position things, how things are shaping globally as well. So we have a 7 focus group within Bharat 6G Alliance. Next slide. In terms of global collaboration, so we as a Bharat 6G Alliance know the, I would say, value of collaborations. We signed MOUs with the multiple global partners. This helps us in putting the views well in advance in a global platform before it goes to standardization. So when TSGSI or an Indian Standards Association goes to those standards body, we have a consensus in one form or the other, or an aligned thought leadership around it. This supports in wider ecosystem of bringing a technology which is more harmonized globally. At the same time, India-specific requirements are well understood before going to a standardization body. So it helps in achieving a synchronized leadership, both technology and the thought-wise. Next slide. So once we discuss all these different aspects of 6G with a global organization, there are multiple interest areas that keep on discussing. Most of you have heard about it. And the 4 things that I always see keep coming in every form of the conversation is, the first is the native intelligence. It's by far the most talked term these days, whether within telecom or outside telecom. ISAC is something totally new, never discussed from the telecom perspective earlier. Spectrum, fundamental, has to be there, but different countries have different perspective of spectrum. Some feel, I would say 7 gigahertz is good enough, some have a different opinion, but consensus is that along the world, 7 gigahertz are one which will be the first golden band that will be available, but there are certain challenges around as well. Not every country has this as a clean spectrum. Finally, NTN as a part of providing ubiquitous connectivity. Certain other things in terms of IoT, M2M, enhanced I would say communications and all. These are still talked, but these are more in the enhancements of 5G. But if you look at the green color symbols, the AI native spectrum, these are not the one enabler, one vertical enabler. They are the horizontal enabler for all the things that we do in the network now going further. Spectrum was always there. Native AI is the new enabler that will help in achieving efficiencies which we have not thought of earlier. Next slide. So having that thing kept in mind, my observation particularly is that the 6G will be focused around more the fundamental pillars that IMD has defined, but with the AI flavor embedded in each and every aspect. Native intelligence will help in achieving the efficiencies or the gains that we have not thought of earlier beyond the standards or adding to that as well. More and more alignment is that globally the structure for 6G needs to be simple yet modular. And with the modularity, simplicity can be achieved when there's an autonomy in the system. Different modules can interact, interop, take decisions learn and react, something like a human intelligence. That only can be enabled by an intelligence layer in the network very aggressively. Unified sensing. Sensing is something which is totally new. For 6G networks, integrating communications will achieve new set of interaction with the physical world, which was not there earlier. So all the cyber physical interaction that we have thought of in terms of sci-fi movies, it's going to be real, but AI still be needed to interpret, analyze data which is gathered so heavily in the network. Next is the autonomy in terms of agentic communications. So agentic AI is something which is totally changing the world from the rest of the industry. Telecom networks will not remain indifferent to it. Different forms of agents may crawl in either via standards or on top of standards. But agentic control is that I foresee or I observe in the conversations that it is going to be the main thing to bring the efficiencies. Finally, two things which was always there in the network that will evolve further in 6G is the sustainability by design and the trust in the network. These two things will evolve further, and new paradigm also needed because you are bringing AI in the networks. You need to have different checks and balances, and more zero trust architecture where everything is checked and verified will be the part of the basic architecture. Next slide, please. In terms of Bharat 6G Alliance working group activities, the current activities that we are doing aggressively is first one is the spectrum strategy for India. First report we published last year. Second report is work in progress. We are also contributing in the preparation of WRC 27. At the same time, a white paper we are creating with the help of partner organizations, how the AI should behave, how AI should act for the 6G networks. More on common thoughts so that industry get aligned to it. And we can also, I would say, keep on evolving these views as we go towards the standardization of AI in the networks as well. We are also contributing in terms of joint thought leadership with the 6G flagship project of Finland, where we are working on joint white paper on resilient 6G networks. Collection of different things makes different things better, and we believe in collective approach and execution of the strategy that we have thought for 6G as a nation and 6G for the global. Next slide. In terms of use cases that we observed, diverse number of use cases. You might have seen these use cases earlier as well, but 6G is going to be different because you have a different source of data getting aggregated. Again, I'm a big fan of AI, so AI is needed. And immersive communication will get more enhanced because you have fatter pipes available, hyper reliable low latency will be there, so you can take quicker decisions and better visibility of the things that you need to have. Coboards are there today, but not for the wireless networks. Coboards will also evolve, where all collaborative machines will do the things in the areas where there's a human health hazards possibility is there. And industries, transport, IoT, everyone will use network more as an integral part of doing things for them rather than they are looking at networks as just an enabler for connectivity. And sensing will evolve much further. Different use cases will evolve that me or most of us have not thought of so far, but it's an enabler that will change many things if we do it right in the standards and we do it right in the networks as well. Having said that, AI will also change significantly. What we see AI today will not remain same from the technology itself perspective. So whenever we are taking decisions for a technology which is 5 years down the line or 4 years down the line, we should also keep in mind that AI will also evolve, the computes will also evolve. So we should define or design 6G keeping in mind the end state, not the today's state of AI. Next slide. Some of the key takeaways, our ambition is to position India as a 6G leader in terms of not only as an independent thought leader, but a technical leader in collaboration with global organizations, help in establishing ecosystem of our research and development and standardization. Collaboration is always a key, and we are active supporter of it to achieve Bharat 6G vision. India as a country need to differentiate, but we need to coordinate as well to achieve the economy of scale for a global deployment. Finally, developing an inclusive 6G ecosystem for a better India. That concludes my presentation. Thanks a lot for the patient audience, and I think I'll take a question at the end.
So I'd like to thank all the speakers. So now we'll go to the exciting thing of panel discussion. So I've already introduced 3 speakers. Okay, I think Dr. Atrashi is also part of the panel. I'm sure. No? Okay, fine. Okay. But fine. So we have 4 speakers. So let me introduce the other 2 speakers before we proceed. So first, I would like to introduce Dr. Mustafa. Dr. Mustafa is a vice chair of ITUT SG13 and its African regional group, contributing to global standards for IMT 2020 and 2030, cloud native networks, and AI-driven orchestration. As senior manager in the technical standards and network integrity development department at NCC, where he oversees national alignment with evolving international telecom frameworks and leads initiatives in next generation network deployment, QoS by QoE policy, and emerging technology regulation. Welcome, sir. Next. I'd like to introduce Dr. Havish Kurapati. Dr. Havish has almost 30 years of experience with Ericsson in wireless communication systems. He has participated in standards efforts in 3GPP, ATIS, TIA, IEEE, HC, and ORAN standardization bodies. He currently works on 6G system as the technical coordinator for Ericsson's contribution to the ATIS Next G Alliance, as well as monitoring 6G initiatives globally. He's a co-chair of the steering group in the Next G Alliance, as well as a co-chair of the ATIS Open RAN Committee. Welcome to the panel, Havish. I don't know if they're audible. Can we just check once for them?
Yes, can you hear me?
Yes, that's Havish. Okay. Yeah. Hi, welcome. So similarly, can we just check with Dr. Mustafa?
Oh, yes. Thank you very much. I hope you can hear me. I'm here online. Thank you.
Absolutely. Okay. So I'm going to, so we'll have 3 sets of questions. The first question is for Dr. Mustafa. Okay, so the question is how the anticipated use cases and TPRs will fundamentally differentiate the 6G networks from 5G networks. What are your views on that?
Thank you very much. Good morning, good afternoon, everybody. It's morning here, so I feel quite honored to be invited to speak alongside the other panelists. It's a real pleasure of mine to be here. When I would like to speak about this, I think generally, from the conversations we've had over the past 3 days, a lot of technical issues have been discussed, as a lot of the use cases have been discussed. Now, I would answer this question by taking a shift away from so much of the technicalities. I want to look at 6G. I call 6G as the network of the village people. Why do I say the network of the village people? Because you see, I'm happy we're having this conference in India, where just as we have in Nigeria, we share a lot of rural communities that we're always trying to see how to get them online to mobile networks. So most of the use cases I would like to focus on more towards the situations where we have the integration between the non-terrestrial networks and the terrestrial networks. Basically, the things like, we have the direct to device, all of this are being worked on. So these are going to be consolidated, if you like, call 5G the enabler of these technologies. But these are technologies that will be consolidated at the 6G level, and this is an area I have a lot of interest in because, like I said, our rural people, they are people that we need to get on the usage of mobile telecommunications. A lot of the access for them is very important because we can't move forward so much and forget them behind. And the India, as well as a lot of other developing countries, we have problem of being able to extend connectivity to these people. So I think the integration, if you like, of that non-terrestrial networks is going to play a significant role in the use cases in 6G. And now, like our focus to be quite significant in this area because this will integrate the rural and the urban, so it will bridge that digital divide, if you like, in terms of those rural people as well as this. And there are areas as well as sensing and other areas that a lot of people have discussed. But like I said, for me, it's that use cases of that non-terrestrial networks being able to have direct-to-device access for people in those rural communities. And I think a lot of the work that is being done currently in terms of this needs to focus on one, bringing down the cost of device so that though such use cases can actually be actualized, because the cost of device plays a significant role in the acceptance and the availability and utilization of the 6G network. So thank you very much.
That's a very, very interesting thought. I'm going to get back to you on this shortly. I mean, it actually is very close to our heart. It's coverage and connectivity issues in rural areas. I'll come back to you. The next question is for Havish, Dr. Havish. So you have been an expert in standardization. You have worked with a lot of SDOs and as part of Ericsson. I just want to ask you a question about ITU and what you think about this. See, ITU looks at defining the requirements of IMT technologies, and in particular, at this point, it's defining what 6G is going to be all about. Okay, so in 5G also, in IMT 2020 or 5G also, ITU has done this. They have put some spectacular numbers, and we know the current situation of the networks. Okay, we are not meeting most of them. Because of that, there's a huge backlash from both government organizations and consumers saying that 5G is not successful. Okay, so how can we ensure that 6G does not go the same route? I'm participating in ITU, and looks like 6G is also very much following what 5G is doing. That's one question. And second question I want to ask you, because you also are part of a company, do you think that there's a lot of 3GPP influence in defining the KPI at ITU?
Yeah, thanks. First, I should say that thanks for the invitation to be here on behalf of the Next Year Alliance. So, to answer your first question, I think the ITU sets requirements, right? And it basically, as Atarashi-san said in the beginning, there is, there are IMT, we have IMT 2030, which is basically kind of like, equivalent of 6G, let's say, and those are the requirements that are kind of like the guidepost or the goal that everybody would like to meet. But then there is also the realities of, businesses, markets, which can be different in different regions in the world. And 3GPP, when they develop specifications, those specifications have to meet those needs. And if they don't meet those needs, then they're either not deployed, or the networks are not deployed, or those features are not developed, or they're inadequate, and you have to then wait until the next release to kind of enhance the feature to do it, right? So I think it's important to. So the ITUR requirements are quite important. At this, and we have to get them right in the sense that we should make sure that they are not. They're not too far out of reach of the current state of technology or the state of technology in 2030, right? At the same time, you also don't want them to be too weak either. So you have to kind of put them, let's say, in some kind of sweet spot. But it's also important to understand that it's very hard to predict, how things will go, say, when you're developing these things. I mean, in standardization, and especially on the ITU side in requirement development, we have very long timelines. And as Sandeep also said earlier, I mean, especially now in the age of AI, the pace of technology development is actually only increasing, so that we are seeing changes at faster and faster timescales, right? So I think predicting exactly what we will be able to do and things like that, even 5-6 years down the road, it's becoming hard. So given that reality, I think we just need to make sure. So the task in 3GPP and in ITU are slightly different. I mean, in 3GPP, the specifications that are developed need to make sure they meet the ITU requirements, but also in situations that are needed, we may have to exceed those requirements to meet business needs and market needs. Then coming to the second part of your question about, let's say what happened with 5G, right? I think when it comes to meeting requirements, as we know as engineers, it's not just what the specification says, right? It's also what nature of deployment do you have, or there are lots of implementation factors, deployment factors, operational factors, spectrum issues, resource factors. All of these come into play to determine whether you're meeting a certain requirement or not. And so we have, I think, maybe two kind of lanes of disappointment, if you can say, with 5G. On the one side, I think from a user perspective, people say, I was doing video on my smartphone with 4G, and now I'm doing video with my smartphone on 5G. So why do I care, and what is the difference? Then I think from a related perspective, operators are also similarly saying, except in some regions where the capacity constraints are, quite strong and things like that. But in many parts, especially in the West, I think we have deployed 5G, we have spent a lot of money on it, but we are not necessarily getting new revenue, right? So the monetization aspect has been disappointing. So I think fundamentally, it's not necessarily a situation of some kind of weakness in the technology itself. I think it's more that we build communication technology, and the technology sits within the broader scope of a bunch of other technologies and an entire ecosystem, right, that deliver services to users, like display technologies, and now with AI coming on board, what kind of new services and use cases there are. So I think we have to keep evolving our networks, both with the ITU requirements and in 3GPP, and then we will hit an inflection point where suddenly there'll be so much demand that we may be forced to actually exceed these ITU requirements with 3GPP technologies, and maybe 6G. Well, I'm optimistic that in that time frame, the discussion will be different. We'll be looking back at 5G and saying, we were thinking about how things didn't really succeed, and now we have to build faster and faster networks in order to meet them.
Okay, got it. I'll come back to some of the things that you have raised in the subsequent questions. The next question is to Mr. Sandeep Sharma. So 5G, we had this whole SA and the NSA business where things confused people, operators, everyone. So are we going to do the same thing for 6G, or are we going to say 6G is going to be a clean network? I mean, there's no relation with 5G. What do you think are the pros and cons of both of those?
Yeah, Professor, I think you raise a very valid point. I think in not only 5G, if you look at 3G, I think the transition we did, it was in multiple steps. And somehow industry and the ecosystem doesn't gel very well in so many changes in the network, because we need to look at ecosystem as a whole. I think in 6G, the way I see conversation happening, it's going to be more simpler and flatter architecture. And it's going to be SA, no need of having multiple transition steps. It's do first thing right and get all the technologies enabled on that vanilla fabric that we are doing right. Implementing things in a step has its own challenges. I think those challenges as a whole, if you look at 3GPP first meeting that has happened few weeks back, is this general consensus from the operators as well and from the bigger OEM ecosystem and the participants. Keep it simpler, but there's a need of modular architecture now. Modular yet simpler architecture, and give as much as flexibility via software upgrade to the network rather than using a drastic hardware shift. I think certain hardwares which are more centric around frequency related, those will change. But if you're keeping the frequency same, keep changes as a software, not a hardware.
So just building on this question, the next is for Dr. Rao. So essentially, how do you think the hardware development and the spectrum policy are linked? And what should we do in this regard so that we have an edge in hardware development?
Hope you can hear me.
Yes, yes.
Thank you. Thanks, Professor R.K. It's a very valid question. So end of the day, we need hardware in place. We can make the standards, still nothing going to work. So the way we always had a trouble of somebody decided the frequencies and we started looking for the devices, components and making it, and we say that our solutions are expensive because somebody had their own IC and fabricated exclusively for them. So that approach always added advantage for the international players. We have large market. They decide the configuration of the hardware, especially the RF side, and they have it run for them. For the entire Fab Lab will do the complete run for them. They get in a couple of dollars, $1. And same thing you want to procure from a vendor who manufactures them and buys, and we buy from them, it will go to 10x. That's why our solution becomes, the way we visualize in 5G, it's going to be expensive. That's why the current scenario, you also be aware of it, we started building these devices to be part of now we are already enough time available with us. We are only at 25. We have at least 2 to 3 years time with the kind of the ecosystem in India. We need to start identifying this typical RF hardware. We're not going to be much different. It's not going to be complete that we cannot do. Only the access to the Fab Labs. Only we need to be very focused instead of simply building so many types of hardwares. Focus it, create a kind of a consortium, or maybe called as a kind of a body on which we decides these are my frequencies, these are the devices. I need amplifiers, doing a gallium nitride or a SiGe, or maybe I have CMOS or BiCMOS, what components I make, or I take that what the gas, what device make. We need to create a kind of some chart and identify the players and the champions within the country and make them as completely answerable and focused only for that piece of work. At least 2 years, a focused research on these devices will get an advantage for us to build our own stack. Otherwise, we'll be again buying and it's going to be a costly, expensive solution. Because you are buying something for our project, your project, and maybe it's very tiny, no user been around. Instead, we need to have our own defined stack, defined RF systems there. Coming back to the spectrum, that's the first question. Spectrum, neither you have choice, I have choice, something going to come from somewhere else. This is the place where we need to be very clear, at least what to be adopted for India within that band. Suppose 6.7 or 7.2. Some people push for 6.7, some may push for 7.2. We need to have a proper understanding within our own multiple already deployed systems. We have satellite systems there, we have the other military communications, we have radar, strategic solutions. We need to have our own slice of the spectrum, what we call within the band, very, very specific, and that should be focused by itself by at least by 25 or 26. By the time ITU comes out with their frequency, IMT 2030, within that, immediately we should identify. It's not that till the auction is done in 2030, nobody knows what could be the frequency allocated within Indian operation. We'll be very clear, at least for India, at least in Asian region. Identify the frequency, start focusing entire RF, entire hardware development only in that band, so that you don't need to redo it. Remember our own experience, we did in 3.28 gigahertz, suddenly said, no, 28 is not free, do on 26 or 24. We should not be repeating, we don't have time to do that, because it's such a fast pacing, this thing. And second thing, the buzzword of this AI coming everywhere, putting so much of, we need to be very cautious about, does it do the good job for you or a bad job for you? And the hardware side is not going to do miracles. We are not going to do miracles.
I'll get to this point. I'm going to talk to some people about that.
Right, please.
The next question is for Dr. Mustafa. Just following up on what you have said earlier. See, 5G and 6G, if you look at 5G and 6G, they mainly talk about high data rates, latency, mobility, which actually is the main focus is about the urban regions, who can do a lot of, who have larger output. See, still basic connectivity is an elusive thing for a large set of population in the developing countries. I mean, see, this is just not a purely deployment issue, it's a technological issue also. So what do you think 6G is going to offer from your perspective that is going to bridge this divide, this digital divide for urban and rural? And at least at the end of 6G, we can say comfortably that with a decent network, we can cover most of the population of this earth. Dr. Mustafa? You're muted, please. Dr. Mustafa, can you hear us? I think you hear the connection. Okay. So meanwhile, then we will, while he's, I think maybe he will be reconnecting. I'd like to ask this question to Sandeep on the AML part. So how will the AML influence the 6G networks? Okay, first of all, AML is now everywhere. It's all pervasive. Without AML, you cannot write papers, you cannot sell products, you cannot do anything without that stamp. But if you look at what is happening in both 3GPP and ITU, still it's not very clear on how AML is going to help 6G. That's one thing. And you have briefly spoken about how 6G is going to help AML in terms of ChatGPT. Can you explain this a little bit more? I mean, do you think it's going to be a fundamental aspect of 6G AML?
I think when we talk about AI, I think there are two aspects of AI. One, AI as a service for the end consumers in 6G era, more aggressive service. Second, AI for the improvement in the architecture, improvement in the performance of the 6G network itself. And approach to these two things are totally different. First is, if there's a lot of, let's take the things first, for example, from the network perspective. If you look at many decisions that are being taken today in terms of which parameter to optimize, how to optimize, in one form or the other, that AI is already there in the network. What happens today, generally in the industry, where the people who are not too much into AI or technically into the networks, that they believe whenever we are talking about AI, it's going to be Gen AI. But it's a mix of AI and Gen AI that will make the network more efficient. You need to define where your use case is justified for a normal AI or a traditional AI where only normal ML works, and where you need an AI which is more generative, you need more, I would say, model context well known in advance for the network so that they can take some corrective actions. But having that type of autonomy in the networks where the networks takes decisions on its own, it will take its own time, networks will learn over its own time. This is from the network's perspective. If you look at from the end consumer perspective, the type of data, in a layman terms, it looks like just a data traffic which is going when we are doing an inferencing or a training in the network. But it's not a data which is predictable. Sometimes if you're generating a content as an end consumer, it requires a lot of data. But if you're generating only a query which is text-based, it is a very small data. How you differentiate that AI traffic on the network? You need to define either a different QoS or a different plane which was not known for the networks earlier, so that that traffic, whether in terms of it is for end user or in terms of control of the network, it has to be did differently. That type of enhancements is needed or needs to be studied before putting it into any standardized standard form.
Got it. I'll question you more on this subsequently. So
apologies, I was disconnected while you were asking, so I hope you can hear me and I'm back now.
Yeah, sure. Were you able to hear my question or should I repeat it?
Please repeat the question because...
Yes, I'll do that. So the question I was asking was, if you look at 5G, 5G specifically, 6G is of course not defined. It talks about mainly about data rates, latency, mobility management. If you look at the spec as well as the KPI requirements, it looks like it's focused for urban regions where there's a lot of machinery, there's a lot of gaming and other things happening with larger ARPU. So basic connectivity is, at least in my opinion, basic connectivity is still elusive for a large population in the world. So some people say it's a deployment issue because you are not deployed things, dense networks, so things are not happening. But I still believe it's a technological issue. So how do you think 6G is going to bridge the divide for rural areas? What is your opinion about, is NTN the only way, or is there anything else that you also feel that will help to bridge this divide?
Thank you very much. When it's like you said, it's not just when you talk about bridging that digital divide. For example, not if we talk of the NGN and the terrestrial and non-terrestrial, we are talking more from the network perspective. So, but I think one of the key areas, like you rightly note, is that there is a lot of sensing application that is going to go on within the 6G systems. So, for me, I still try to focus as much of my conversations around that rural connectivity, because I think that's a very key issues. So there is another area, if you like, for me to look at is, generally, if you look at our societies, the rural communities are the ones who are much more into the agricultural use cases. They are also the ones who tend to have lack of access, if you like, to medicine, healthcare, and issues like that. So when you talk about the general difference in terms of the 5G and that 6G, at the 5G level, like I said, now Hiroki is here. He speaks about it from the ITUR perspective. So now, from looking at it from more of the ITUT, our perspective, you see, in study group 13, we have 13 questions. One of the key questions is the convergence between satellite networks and terrestrial networks. Study group 13 deals with that issue. And if, as you're aware, in terms of, like you said, those requirements have not been set. But if you remember last year, the WTSA was held here in India, New Delhi, and the IMT 2030 was now actually added into the responsibilities of study group 13 to be able to develop requirements as well as those network architecture and frameworks for the 6G. So if you look at the work being done within study group 13, the issue of quantum computing is also there. Quantum key distribution requirements and things have been set for the quantum networks, and this will be a key player in that 6G generation. So in essence, I think the key focus areas for that rural urban digital divide will also now go within, like I said, the areas of agriculture, smarter agriculture. That sensing in 6G networks will play a key role, especially in that integration of the smarter agricultural farming. And then the other challenge we have to deal with, unfortunately, is a bit of, if you like, capacity building, especially for the rural communities. Now, we can talk about how smart agriculture can be, and how telemedicine can work. But if the rural people are not equipped to use the systems, we're just developing systems that are not going to be much more beneficial to these people. So in terms of technical, differences, if you like, is like I said, there is not much non-terrestrial integration in 5G at the moment. So 5G in terms of capabilities, in the urban areas, we can have our, 200, 120 gigabits per second speed and all the speed we want to get. But once we go to that rural areas, they have a disconnect. Their networks, as much as are connected, but they don't have 5G capable connections within those areas. And this is primarily, if you like, I wouldn't say down to technology, but there is an element of technology in there, because then we are still unable to extend our 5G services to those rural communities. So that where we would have that advantage in that 6G is if this use cases of being able to integrate this capability, so it become a technological issue that we are able to develop the seamless integration between the NTN and the non-terrestrial networks and the terrestrial networks to be able to now extend those services. So now what you have is those terabits per second speed that we expect to see in the 6G networks now goes straight to the rural communities with a direct connection, to the main network. So everybody, the whole ecosystem gets to enjoy the full benefit of 6G, because then if you have challenges of extending the 5G networks where connection maybe via fiber laying in rural areas is a problem, then you have that technological advantage of being able to use satellites to be able to utilize those. So I think to summarize it, those areas where we have the issue of smart agriculture, healthcare systems for the rural communities will be bridged by being able to utilize the 6G networks. But also, we have to talk about it as well, like I said, from the perspective of being able to carry these people along the rural communities. It's not just enough to have the 6G networks for us in the cities and urban networks, but how do we bring them into the fold? So that's a very important area. Thank you.
Thanks, Dr. Mustafa. We will dwell on that again sometime later. So the next question is for Dr. Havish. Dr. Havish. So I just talked about sustainability. Sustainability is a very important goal. What are the key aspects of sustainability for networks, and what should be done from the beginning of the design to implementation stages to address these aspects? For example, energy efficiency. What do you think are your views on sustainability? Sustainability has now become part of ITU jargon in IMT 2030. I mean, what does this mean in terms of networks for 6G?
Yeah, I think sustainability, as with AI as well, but from a completely different angle, sustainability is also extremely. It doesn't make sense to look at it unless you look at it very holistically and in a very broad sense, right? So, for example, in the NextG Alliance, in the so far in the Green G working group, some of the work that has been done has tried to emphasize the need for the circular economy principles, and to look at not just the entire network, but also where, for example, operators and vendors of mobile equipment are sourcing their components from, how they are actually generating power to power their their deployments, and as well as then once the life cycle of the equipment is done, then how do you kind of make sure that all of this is recycled back in a responsible and sustainable way, right? I think so. That's one thing I would say about sustainability, that looking at it holistically is super important. The second thing is that I think sustainability is getting a lot more focus naturally now, of course, because of the more acuteness of the climate change issues that we may be seeing. That's one thing. But it's also because the energy costs for operators are actually... can you hear me?
Yes, yes, sir.
Yeah. So because the energy costs for operators are also becoming a significant fraction of of their expenses. So any amount of savings that you can get on those costs, I think, is of high importance to operators. The other angle, from a technology angle, I think it's also complex because it depends on what level we are talking about. So, for instance, on the radio side, what is very important to get right in the standard is to ensure that we have enough flexibility, and the standard has enough. The radio signals that we standardize that need to be transmitted all the time are lean enough that you have ample periods for the power consuming radio hardware to turn itself off and get into deep sleep mode. So I think we have made a lot of progress in 5G compared to 4G. In 6G, we expect that we'll make even more progress on this side. Now, this is a particularly challenging problem because what you take away from the base station, you give to the UE and vice versa. So we have to kind of find the right balance between, like, if you make it way too lean, and if the UE is spending, and there are, millions and billions of UE spending a lot more time trying to search for signals, then it's a bit complex. So we need to design it, we need to find the right balance, and we need to make it flexible, right? But then I think sustainability has many other angles. For example, on the network operations side, there's a lot of interest in using AI, for example, to do traffic steering in a way so that maybe we can take opportunities to turn off cells when we don't need to keep them on. And similarly, when it comes to mobility and handoffs and things like that, and also simple. So again, kind of making a bridge to AI. I mean, one of the evolutions that will happen for network management is to go to these so-called intent-driven management networks, so that we are able to, at a more higher level, provide some intents to the network on what to optimize. And these will provide actually more opportunities on the sustainability side as well, because we can kind of provide criterion to say, it's not just about squeezing out the maximum amount of performance, but also what is the energy cost of this. So we can put constraints on it and say that, unless you meet these energy constraints, don't give the bandwidth, right? So there are multiple directions like this. But the good thing, I think I would say, is the ITU is now highlighting sustainability as an overarching aspect. I think the industry has much more awareness on this issue, and we have come a long way. When I first went to standards in 3GPP for 4G, the very first thing I went to 3GPP for was to try to reduce the frequency of the CRS. And most of the feedback I got was that, this is, how can I justify this to my managers? And this is very weird and so on. So when it came to 5G, it was not questioned so much anymore, although there were like a lot of arguments. I think now when it comes to 6G, we are like embedding it right in the ITUR requirement. So I think we have come along.
Thank you, Ramesh. So the next question is for Sandeep. So we are all talking about AI, and you said that AI is going to change the way we are going to operate networks and consume data and everything. But AI is also going to increase the cost of the network. At least if I just look at the price of an NVIDIA GPU, I think you can deploy like 4 base stations for one card. So how do you think you're going to manage the trade-off between the cost and the benefits of AI, specifically in a country like India where we are very price sensitive?
I think, and I'll use the line that I said in my presentation, where we are comparing future of 6G with the current state of GPU. I think the GPU industry will also evolve the way I expect. The energy efficiencies, or I would say, when you talk about sustainability, always it's made it as synonymous to energy efficiency. It's not. If you look at sustainability, is like holistically in ecosystem, what type of efficiency is that bringing AI? Different use cases, different adjacent industries will also evolve. They will reduce their carbon footprint using AI. And GPU is used for compute because no other strong processor which is available for it. The way I see the compute industry will also evolve, more focused processor which will be more efficient for processing AI specific loads other than general purpose compute. So those type of evolution will also happen parallelly. I think we should not discount importance of AI just because the current state of AI appears to be more power hungry or more cost hungry.
So you are saying that we wait and watch. You think that the things are going to become better and from an AI perspective? It's evolving. Oh, that's the word you're using. Okay. So, do we have time or we are running out of time? I don't know. Maybe started 15 minutes late. We have 5 minutes. Okay. So I'm going to ask this question for Dr. Rao. Dr. Rao, so I want a quick answer on what do you think about quantum for 6G? Because there's a lot of hype about quantum. Not hype. Actually things are happening, but do you think it's going to have an effect on 6G? If so, where? Okay, short answers on this. We have to couple of rounds. We have to stop this up.
Maybe just in a couple of sentences, I'll say that the way the people envisage the quantum to deploy onto a kind of a coverage-based solution as the 6G, a cellular network, I find it going to be much more very complex to even to visualize or maybe just imagine it can be done. But yes, there are the places where, because the security is involved, including the having the quantum computing, going to have a huge impact there in terms of the security aspects, which we are attempting for the strategic applications. Expecting them to be a deployable solution, I don't think. I mean, I'm not convinced yet. Probably I may change my mind. As of now, I'm not convinced it's not a deployable. Quantum communication is not a deployable solution as part of 6G.
Taking the line from Sandeep, it's quantum computing may become cheaper and smaller going forward too. So
Maybe.
okay.
Still is a complex to implement, Professor.
It's
Okay,
very
still
complex.
to implement.
Okay. Because there's a lot of people are worried about 6G. I mean, how 6G is going to play a role on this. So I'm going to. This question is for Dr. Mustafa. So suppose if I give you a chance to introduce some technology in 6G, we say that whatever Dr. Mustafa says is going to happen in 6G. What is that thing going to be?
It sounds simple, but it's a very, very complicated question in itself. So for me, what I would like to see in 6G as a use case, to be honest, is a situation where, if you like, we already have the VR usage and things like that. So I would really like to see the proper evolution, if you like, of the metaverse in the 6G, where everybody is interconnected into this metaverse and everybody gets to explore a different world. Thank you.
Fantastic answer. I like that answer, sir. So essentially, this means you require URLLC, you require all this technology so that we have a connected world. Essentially, that's what you're saying, connected world via 6G. Very, very nice. To Dr. Havish. So from the perspective of standardization, do you think that all our NextG Alliance, TSDSI, all these alliances, the multiple 6G alliances have been formed across the globe, are we talking enough? Do we just meet during these conferences and then write notes and go away? Are we actually meeting together and putting our thoughts together and coming up with something conclusive that can be provided? I mean, that actually will be a global thing. What are your views?
You mean between different organizations globally?
Between different organizations, are we talking enough? That's what I'm trying to say. Not SDOs, between the 6G Alliance, NextG Alliance, and so on and so forth.
I think that's let's put it like this. I think more interaction doesn't hurt. So I think so I wouldn't say that we are in bad shape, but at the same time, because we have had contacts, I think, between various global organizations, that has been quite good. But of course, more interaction is even better. So I think there are opportunities for that we could take advantage of to understand the ecosystems on both sides very well. And excuse me, one thing I would say is that I think it's very important. The entire success of the mobile industry overall has been the enormous global scale. So I think what is super important is that from every region, while we think about the needs of that region and we have alliances and organizations in these regions, it's still important to think global. So I think from that perspective, it is very useful, for example, to understand the Indian perspective and and similarly the North American and the European perspectives, etc. So yeah, that would be my short answer.
Okay, thank you. So what are your views on the security summit from a Bharat 6G Alliance member?
Yeah, I think I'll agree with Havish. There's a need for more combined joint thought leadership, and we started with few organizations and happy to work more with the NextG Alliance as well. Combined thought leadership is needed so that any isolations or any delay in the standardization could be avoided. This is my short and simple view around it.
So we should talk more. That's a simple answer, I think so. Okay, so can we open the questions for the audience? Yes, please.
Yeah, thank you so much, sir. So I have two questions actually. One about the ubiquitous connectivity we are talking about, and what I understood actually, NTN will be the major solution for ubiquitous connectivity. But will it be affordable? Because at the same time we want to have it affordable, and mainly we want to cover the rural areas. So whether it will be affordable, are we also going for some technological development like 5G in case of 5G, something like that? That is the first question. Second question, what you think actually the typical use case of sensing ISAC that will be available on day one of the launch of 6G?
So can I request Dr. Mustafa to take this question? I hope you were able to hear that question.
Maybe you may help me refresh, but what I understood is one of the advanced use of sensing, if you like, in the 6G.
He's asking that NTN is going to be is thought about as the main driver of ubiquitous connectivity. So do you think NTN non-terrestrial networks are going to be affordable? Are they going to be expensive or affordable? I mean, what do you think? That's the question he's asking.
Okay, thank you. Let me give a different perspective or a different use case. Maybe that might be able to answer this question. So, look at it from this perspective. For example, I know, like he said, on the side of equipment and devices, this can be quite an expensive solution when it comes to that. But the beauty of it, or if you like, the opportunity it creates is an opportunity we see. Let me give a use case in Nigeria, for example. So let's say we have NGSO satellites that are providing very good internet coverage services. So obviously, like you said, from the perspective of equipment cost, this can be a very high cost, but it has created an opportunity, which is, for example, so you have situations where you have people who now, as from a business perspective, go and purchase this equipment, and then, for example, they go and deploy it in markets, maybe markets or rural communities where now they are the ones with the equipment, but they sort of, if you like, subsidize it to the end user. So it's a situation where they now deploy the systems and then use maybe smaller networks, for example, maybe use other equipment using Wi-Fi 6, Wi-Fi 7, and be able to deploy this to a wide range of people. So it's a win-win, if you like.
Innovative. So we have something called a PCO earlier. He's saying a PCO model for non-terrestrial networks. So one guy buys the equipment, puts it, and provides service to others. It's a very, very innovative way of looking at this thing. So the second question that he asked is, what will be the main use case of ISAC? I would ask Dr. Havish to take this up. The first use case, not the main. Immediately when 6G release 20 comes out, what would be the first use case of ISAC?
What will be the first use case of ISAC? I think there's a lot of interest in things like drone detection, and for example, in China they talk about this, the aerial economy. I don't think I have the terminology right, but so I think that one of the things with ISAC is that if I have to put it frankly, I think we have to be careful about overhyping ISAC. I think it is a very important addition for 6G. At the same time, the viability and performance will vary wildly between use cases. So, for example, for things like drones where we have line of sight, I think you can do quite interesting things. But when we are talking about sensing things deep inside clutter on the ground, the link budgets will go down, and the amount of ambiguities we'll have. So, the kind of use cases that may in the end be viable, we have to see. I think it really depends on the deployment. But I would say if I was to point to one thing related to ISAC, maybe something to do with drones is what I would be most.
So Dr. Havish's answer is it's going to be drone detection. That's the first application of ISAC.
If I may add to this.
It has to be. Hello. Many thanks. Another problem is that we are talking the NTN for the 6G and all this. Yeah. NTN has got a dual uses. Okay, civilian uses and the military uses. And if you look at any NTN platform, I'm saying, it's 50% or 60% of their business plan is military plan. That's one. Second thing is that they don't talk about that. And the second thing is that telecom is a highly restrictive subject where the terrestrial model goes there, where it's basically if we are bound by that, we will not allow the communication to go. When we are doing this particular thing, NTN, in that particular it doesn't follow the geographical boundaries. We are forcing them to follow the geographical boundaries, but again, your basic infrastructure is not yours. How are we going to tackle the issue? That's my major problem is that we are talking a lot here and there. That's one.
Yes,
second thing, if you are taking the LEOs in that particular position, the capacity to utilization maximum whatsoever do cannot be more than 40 to 50%.
Okay, so I'll give you my view on that. Okay, so to speed up things a bit, see, according to me, NTN is going to be there, but it's not going to be a major player for providing connectivity or capacity. I think it's just to serve people in pockets who are really not connected. I mean, maybe you are going on a hike and you want to ensure that you're connected, you can't do that. I mean, you are absolutely right. This whole notion of data seclusion for countries, these are big issues that policymakers have to think about. You have time for one question? Or no. Bindu says no. So I would like to thank all the panelists. We had a very great discussion. I would have loved to meet you personally here, but thank you for joining at different times. So specifically, Havish, I think it must be early, very, very early morning and late night. Thank you, Dr. Mustafa, Dr. Rao Garute for taking time out of your busy schedule and joining, and Sandeep for being here as my sole participant at the live thing. Thank you.
Thank you, Professor.
Yeah.
So it's a pleasure.
Thank you.
Just
Thank you very much. It's a
we
pleasure.
have to take a virtual photograph so that we know that this panel has happened. Please be there. Switch on your cameras. We'll take a virtual photograph. Thank you, everyone.